Alright, trig class, we're being asked in this problem to find the angle that makes the inverse tangent, that makes the tangent function equal to this square root of 3 over 3 on the inside. Again, on a problem like this, I strongly encourage you to have your unit circle out and ready to go. So the inverse tangent function can only output quadrants 4 and 1, and the angles that it outputs are negative pi over, or betweens negative pi over 2 and positive pi over 2. And so that means that this is not 11 pi over 6 as far as inverse tangent goes. It's negative pi over 6. This is negative pi over 4, and etc. They are negative angles, and then these are the positive angles. So if tangent is positive, if you recall, tangent is the slope of these tangent lines, these lines that connect the origin to the points on the circle. They're not tangent lines, I shouldn't say. But because this is increasing left to right, this is increasing. These are positive slopes. These are negative slopes. So when tangent is positive, the angles will be positive. When tangent is negative, the angles will be negative. Alright, that being said, this is one of those special angles that you need to know for tangent. Okay, again, for tangent, it's 0, 1, infinite or not defined, and then there's the square root of 3, and there's the square root of 3 over 3. Those are the 5 values tangent and cotangent can take on if you're at a special angle on the circle. Right? And square root of 3 and the square root of 3 over 3 are reciprocals of one another, just like 2 and 1/2 are reciprocals. So square root of 3 over 3 is the same as 1 over the square root of 3. But I say that because just like there are these 5 values for all the points inside of the unit circle, 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. Right? Those are the values that you see in any one quadrant, just ignoring signs. These are the 5 values that correspond to those for tangent or cotangent. And if you understand who's bigger or smaller, like obviously 0 is the smallest of these, infinity is the biggest of these, and then it's just knowing where the others fit in. So square root of 3 is obviously 3 times bigger than the square root of 3 divided by 3. So that's bigger than this. And then 1 is the number I square to get 1. The square root of 3 is the number I square to get 3. So square root of 3 is bigger than 1. So this is bigger than this. Then this is the smallest of the non-zeros and infinities. So the way this works is tangent is equal to 0. I'm going to put, these are the values of tangent at 0. Tangent's equal to infinity here, because again it's the slope, and that's a vertical line. Tangent's equal to 1 at 45 degrees because it's sine over cosine, and they're equal. So at 45 degrees, or pi over 4 radians, tangent is equal to 1. I'll put 1 right there. And so it's down to this one and this one to be square root of 3 and square root of 3 over 3. Well, this is steeper than this. So that means that this is where the tangent's the square root of 3, and this is where the tangent's 1 over the square root of 3, which is equivalent again to the square root of 3 over 3. So there's your 5 values of tangent, and it flips. The signs change depending on which quadrant you're in. The reciprocals of these are, the reciprocal of infinity is 0, the reciprocal of 0 is infinity, the reciprocal of square root of 3 is square root of 3 over 3, and then the reciprocal of 1 is itself. So when you switch to cotangent and inverse cotangent, these will just kind of switch places around that 1. So this will be the cotangent, this will be that cotangent, and then cotangent of 45 is still 1. Alright, but that being said, now I have the answer that I want. It's a positive square root of 3 over 3. So that's right here. And I want to know where inverse tangent is equal to that. So it's that positive pi over 6. So this answer is pi over 6 there. Alright, so again, making a unit circle, being able to do that like I showed in one of those previous videos, is a requirement, something that you're going to need to be able to do to really make your time efficient when you're doing your midterm and your final.